There is a word that has basically, well, it's just taken over our cultural vocabulary.
Oh, I know which one you mean.
I hear it in corporate training seminars. I see it on, Instagram therapy accounts.
It's everywhere.
It is definitely the buzzword in every single relationship advice column I've read in the last, decade?
Yeah.
The word is empathy.
It's the heavy hitter of social virtues, isn't it? It's presented as this universal solvent.
Yes, a solvent. That's the perfect word. If you have a conflict,
Add empathy.
if you have a leadership problem,
Just add more empathy.
right, it's treated like this monolithic kind of magical substance. You either have it or you don't,
It's a binary. You're an empath or you're a narcissist, and there's no in between.
which is, it's a very comforting way to look at the world, but it is also completely wrong.
Fundamentally wrong, yeah.
And that is what we're digging into today, because when you actually look at the biology, when you peel back the scalp and look at the wiring diagram of the human brain, empathy isn't one thing.
Not at all.
It's not a single light switch.
It's actually two completely distinct engines.
Two engines.
Yes. Two separate neural networks that run on different fuels. They operate at different speeds. And this is the part that I think really trips people up. They can function or fail completely independently of one another.
Okay, so that's the hook for today's deep dive. We are going to map the neuroscience of what researchers call cognitive empathy versus affective empathy.
Right.
And we aren't just talking about psychology here. We are talking about, cortical thickness, white matter connectivity, lesion studies.
Voxel-based morphometry. We're getting into the nuts and bolts.
We're going to see how the brain physically actually constructs our ability to connect with other people.
Yeah.
So if you can, imagine two different road systems in your head. That is the mission today. We are going to drive down both of them.
And we should probably define our terms right out of the gate so we aren't talking past each other.
Good idea. Let's start with the first engine. What's road number one?
Road number one is what we call affective empathy. This is the feeling engine.
The feeling engine.
It's visceral. It's somatic. It is quite literally the sensation of, I feel your pain.
Okay, so when I see someone stub their toe and I physically wince, like I feel it in my own foot?
That's it. That's affective empathy. It's a shared emotional state, a contagion.
Okay, so that's engine one versus the second engine.
That would be cognitive empathy. This is the thinking engine.
Right.
It is the ability to understand what another person is feeling or thinking without necessarily having that same gut reaction yourself.
So it's not I feel your pain. It's more like
I understand that you are in pain, and I can probably guess why.
So the difference between feeling the punch in your own gut and just knowing why someone else is clutching theirs.
Precisely. And the data we're using to pull this apart isn't just, opinion. We have a huge stack of high-impact neuroscience papers here.
And not just old ones.
No, we're looking at studies ranging from some of the early groundbreaking lesion work in 2006 all the way up to comprehensive review papers from 2024.
So we are really covering the whole timeline, from the early discoveries to the absolute cutting edge.
We are, and it really represents a revolution in how we understand the social brain.
So let's get the car out of the garage. I want to start with this idea of the two roads. You called it the dual route model.
This is the foundational framework, and there's a really great paper that lays it out by you and colleagues from 2018. It was published in Frontiers in Psychology.
What was it called?
A dual route model of empathy, a neurobiological perspective.
I love that title because it sounds like a navigation app. Recalculating route to empathy.
It's not that far off, actually. You and his team proposed that empathy operates on these two distinct levels, and they're different in terms of processing speed and consciousness.
Okay.
First, you have what they call the lower route.
The lower route. Sounds basic.
It is. It corresponds to affective empathy. And the key characteristics here are that it's automatic, it's incredibly fast, and it is largely unconscious.
Automatic and fast. So this is the gut reaction we were talking about.
Absolutely. Biologically, this relies heavily on what are called the mirror neuron system.
Ah, mirror neurons. I've heard of these.
The classic analogy to understand this is the hot stove.
Okay, walk me through the hot stove.
All right, so if you put your own hand on a hot stove, what happens? Your spinal cord yanks your hand back before your conscious brain even has time to register the word hot.
It's a reflex. Pure survival.
Right. You don't think about it.
Right.
Now, what happens if you watch someone else put their hand on that same hot stove?
Oh, I wince. I'd probably pull my own hand back just instinctively.
Exactly. You wince. You feel a shadow of that pain. You don't have to stop and calculate, okay, the stove is 400 degrees. Thermal conduction will damage the epidermis, therefore that person is in pain.
No, it's instantaneous.
That is the lower route. Your brain is, in a way, simulating the sensory state of the other person. It's a bottom-up process. It happens to you, not because of you.
Which makes perfect sense from an evolutionary standpoint. I mean, if my tribe mate suddenly screams, I need to be on alert immediately.
Right.
I don't have time to sit there and ponder the philosophical implications of his scream.
Exactly. Is it a saber-toothed tiger? Is it a snake? It's a threat detection system, fundamentally. But then you have the other road.
The higher route.
The higher route. This is the cognitive engine.
Okay.
And this is described as slow, complex, iterative, and conscious. It involves a process called mentalizing, or the more common term is theory of mind.
Theory of mind is one of those terms that gets thrown around a lot. What does it actually mean in this context, neuroscientifically?
It is the cognitive ability to attribute mental states, beliefs, desires, intentions to other people. It's the fundamental realization that you have a mind, it is different from my mind, and I can make a pretty good guess about what's going on inside it.
So if the lower route is a reflex, the higher route is more like an investigation.
That's a great way to put it. It's detective work.
Okay.
You are piecing together clues, the context of the situation, their past behavior, their subtle facial expressions, their tone of voice, all to build a working model of the other person's internal world.
Give me a real-world example where the lower route might fail me, and I'd absolutely need the higher route.
Okay, easy. Imagine you walk into your office and you see a colleague just staring at her phone. Her face is completely blank. She's just frozen.
I'm picturing it.
Your lower route, your mirror system, it might not pick up much. There's no screaming, no crying, no obvious pain face to mirror.
Right, so I don't get that gut punch of shared feeling.
Exactly. You're just seeing a neutral face. But then your higher route kicks in. You start running the calculations.
The detective work.
You start thinking, okay, she had that big interview for a promotion yesterday. She told me she would get the email with the result by noon. It is now 12:05 p.m. A blank stare in this context probably means shock or disappointment. She probably didn't get the job.
Wow, so I'm deducing the emotion based purely on the data.
Exactly. You're constructing an understanding. You're thinking, I understand that she is likely feeling sad and disappointed. That is a top-down, conscious, cognitive process.
Now, you published this model in 2018. That's a few years ago now. And neuroscience moves pretty fast. Is this still the consensus?
It holds up remarkably well. In fact, we have a review paper that just came out this year, 2024.
Hot off the press.
It is. It's by Almeida and colleagues, titled Neuronal Correlates of Empathy, a review of event-related potentials studies in perceptual tasks. This was in the journal Brain Sciences.
Okay, so what do they find?
Well, they looked at event-related potentials, or ERPs, and what that lets you do is measure the electrical timing of brain responses millisecond by millisecond. It's incredibly precise.
So you can see when things are happening.
Exactly. And they confirmed the distinct time course. They saw that the effective response, our lower route, happens first. It's an early automatic wave of electricity in the brain.
And the cognitive part.
The cognitive response, the higher route, comes later. It takes more time, more processing power.
So the biology confirms the fast versus slow model. The feeling is a flash. The thinking is a slow burn.
It does. But Almeida's paper adds a really important nuance. They note that while these are distinct systems that we can separate in a lab,
in the real world, it's different.
In the real world, a complete empathic experience usually requires the simultaneous activation of both.
So we can talk about them separately, we can study them separately, but in a healthy interaction, I should be both feeling and thinking.
Ideally, yes. The fast lane and the slow lane of the highway should be merging. But to really understand what happens when things go wrong, which is where it gets really fascinating, we need to pop the hood and look at these two engines separately.
Let's do it. Let's start with the anatomy of that lower road. The feeling network. If you put me in an fMRI machine and you show me a video of someone getting a needle in their arm, what parts of my brain are going to light up?
Okay, you're going to see a very specific network activate. It's often called the pain matrix.
The pain matrix. Sounds like a sci-fi movie.
It kind of is. And there are three core regions you really need to know here. The inferior frontal gyrus, or IFG.
Okay.
The anterior midcingulate cortex, or AMCC. And the big one, the real star of the show, the anterior insula.
The anterior insula. I feel like this part of the brain comes up constantly in discussions about emotion.
It really is central to so much. The insula is fascinating. It's a piece of cortex that's tucked deep inside the folds of the brain, between the temporal and frontal lobes, and its primary job is something called interoception.
Interoception. That's sensing the internal state of your own body, right?
Exactly. It's how you know you're hungry, or that your heart is racing, or that you have butterflies in your stomach. It is the brain's map of the physiological condition of you.
Okay, so why in the world is it lighting up when I'm watching someone else get hurt? I'm not the one getting the needle.
That is the million-dollar question. And there's a great 2018 paper by Marsh in Current Opinion in Behavioral Sciences that goes into this.
And the theory is?
The theory is that in order to truly understand your pain, my brain literally has to simulate a version of it on my own body map.
So my insula creates like a phantom echo of your distress inside my own system.
That's a perfect way to describe it. It recreates the somatic sensation. When we use the phrase, "I feel for you," that is not a metaphor. Your insula is physically firing as if you were experiencing a mild version of that very same pain.
That is incredible. We are literally hardwired to resonate with each other's physical states.
We are. But here is a fascinating detail from that Marsh paper that I love. This pain matrix, the insula, the cingulate, it's specific to witnessing pain and other negative emotions.
Wait, really? So what happens if I see someone win the lottery on TV and they're jumping for joy?
A totally different network kicks in. If you're witnessing joy or triumph or happiness, the brain recruits a different network for positive empathy.
Which is?
You see activation in the ventral striatum and the medial orbitofrontal cortex,
The reward centers?
the dopamine pathways.
Mhm.
So empathy for pain is basically shared suffering, neurally speaking. Empathy for joy is shared reward. They are physically different roadmaps in the brain.
Okay, but I want to push on this a little. Because fMRI is great, it shows us what lights up. But correlation isn't causation, right? How do we know these brain areas are actually causing the empathy?
That is a very fair and very important scientific critique. And to prove causation, we usually need to turn to a different kind of evidence. Lesion studies.
Right. Looking at what happens when a specific part of the brain is damaged through, say, a stroke or an injury.
Exactly. And there is a landmark study here, an absolute classic by Suri and colleagues from 2009, published in the journal Brain.
What's the title?
It's a mouthful, but it's descriptive. 2 systems for empathy. A double dissociation between emotional and cognitive empathy.
Double dissociation. That sounds like a complicated breakup strategy.
In neuropsychology, it is the absolute gold standard of proof. It's how you know 2 functions are truly separate.
How does it work?
It means you find one patient, let's call her patient A, who has lost function X, but has kept function Y completely intact. Then you find another patient, patient B, who has the exact opposite profile. They've lost function Y, but kept function X.
You prove they can break independently of each other.
Exactly. So Suri's team looked at a group of patients who had lesions damaged to the inferior frontal gyrus, the IFG.
That's one of the key players in our feeling network, specifically Brodmann area 44.
Right. And what was the result?
Let me guess, they lost the feeling part.
These patients showed selective, and I mean selective, deficits in affective empathy.
So paint a picture for me. What does that actually look like in real life for one of these patients?
It means they could look at a photograph of a crying child, and they could tell you completely accurately, that child is sad, I can see the tears, it's likely because they fell down and scraped their knee. They had the cognitive logic down perfectly, but they didn't feel it. There was no emotional contagion, no somatic resonance. Their own internal state didn't change one bit.
Wow.
It was a cold, clinical observation.
That is profound. The feeling fuse was completely blown, but the thinking circuitry was perfectly intact.
And we even see this backed up by structural studies in healthy people, not just lesion patients. There's a 2013 paper by Muchler and his team in Frontiers in Human Neuroscience.
Okay.
They used a technique called voxel-based morphometry, which is basically a high-tech way of measuring the volume and density of brain tissue in 3D space.
Like a topographic map of the cortex showing where it's thicker or thinner.
A perfect analogy. And they found that the gray matter density in one specific spot, the left dorsal anterior insular cortex, correlated directly with how high people scored on tests of empathy.
So wait, physically, having more neurons, more brain matter in that feeling hub can actually make you more empathetic.
More effectively empathetic, yes. It seems so. Muchler calls this area a domain general region, a hub where the feeling of the body meets the understanding of the mind.
Okay, so that is the feeling engine,
Yeah.
the lower route. Now let's flip to the other side of the coin. Let's look at the detective. The anatomy of cognitive empathy.
Mentalizing network.
Who are the key players in this network?
This is a more distributed network, and it's much more cortical, meaning it involves the outer newer layers of the brain. You're looking at the dorsomedial prefrontal cortex, or DMPFC,
Okay.
the temporoparietal junction, the TPJ, the superior temporal sulcus, or STS, and the temporal poles.
That's a lot of temporal and parietal and frontal. It's all over the
It's
place.
a higher order association network. And again, we have structural evidence for this. A study by Uribin and colleagues from 2019,
Which journal?
Frontiers in Behavioral Neuroscience, and they were looking at the neuroanatomical correlates of both types of empathy.
And what did Uribe's team find?
They measured cortical thickness, the actual depth of the gray matter ribbon in the brain. They found that participants who scored really high on tests of perspective taking, which is the psychological term for cognitive empathy.
The ability to see things from another's point of view.
Right. Those people had greater cortical thickness in the left orbitofrontal and ventrolateral frontal cortices.
So let me get this straight. If you're the kind of person who is just naturally good at standing in someone else's shoes and understanding their viewpoint, your brain is actually physically beefier in those specific areas.
The cognitive areas, yes.
Yeah.
And what was really interesting in this study was the contrast. They found that affective empathy was related more to subcortical structures, deep, ancient brain structures like the thalamus.
Which tracks perfectly with the evolutionary timeline, right? The feeling part is deep and ancient and reflexive. The perspective-taking part is cortical and uniquely human.
Precisely. Now, do you remember that double dissociation study from Sori?
I do. We had the patients who couldn't feel but could still think. So, what about the reverse? Did they find them?
They did. They found another group of patients with lesions in a different area. The ventromedial prefrontal cortex, the VMPFC, specifically Brodmann areas 10 and 11.
And let me guess. They had the exact opposite problem.
The mirror image. Their emotional empathy was completely intact. If they saw you crying, they would feel distress. They would start to feel sad themselves. Their mirror system was working perfectly.
Right.
But they failed the theory of mind tasks. They couldn't infer what you were thinking or why you were feeling that way.
So they feel the raw wave of emotion coming off of you, but they have absolutely no idea why it's happening.
Exactly. Imagine being flooded with this intense sadness that's radiating from someone else, but being completely unable to interpret the context or the reason behind it. You're just drowning in affect with no cognitive framework to hold it.
That sounds chaotic and honestly pretty terrifying.
It really highlights, again, that empathy isn't a single skill. It is a handshake between these two systems. And if one of them lets go, the entire experience can just collapse.
But I want to pause on this idea of cognitive empathy being cold. Because usually when we talk about theory of mind or mentalizing, we think of it as this detached, logical calculation. Like Sherlock Holmes analyzing a clue.
Right. Very Spock-like.
Yeah.
Logical and unemotional.
But there is a study in our stack that really challenged that idea for me. It's by Schnell and colleagues from 2011 in the journal Neuroimage.
Oh, this is a brilliant study. I love the design they came up with here.
It's so clever. Walk us through it.
So Schnell and the team wanted to isolate cognitive empathy in the scanner, but they had a big problem. When you show a participant a photo of a person's face, especially an emotional one, those mirror neurons in the lower root fire automatically. You can't stop it.
Right. Faces are basically cheat codes for the feeling engine.
Exactly. So they had to get around that. They used these little false belief cartoons. They're simple comic strips where a character is mistaken about something like they think a ball is in a red box when we, the viewer, know it's actually in a blue basket.
Okay, a classic theory of mind tap.
Right. But here is the brilliant trick. The characters in the cartoons had no facial expressions. They were just blank ovals.
Faceless people.
Faceless.
Right.
So the participants had to use pure logic, pure cognitive inference to figure out what the character was thinking and how they would feel when they discovered their mistake.
They forced the brain to be a detective with no emotional clues to go on. What happened in the scanner?
Well, as you'd expect, the mentalizing network lit up like a Christmas tree. The DMPFC, the STF, the whole cognitive crew was there. But, and this was the big surprise, so did the limbic system.
The emotional brain. But how? There were no sad faces.
Specifically, the left amygdala in the hippocampus started firing.
Wait a minute. The hippocampus is all about memory. The amygdala is the brain's fear and emotion center. Why are they firing if there are no emotional triggers to react to?
That is the core insight of the paper. The authors interpret this to mean that even when we are performing a purely cognitive inference about someone else's state, our brain accesses its own library of emotional memories to make sense of it.
Hold on. So to understand what being disappointed might feel like for a faceless cartoon character, I have to first dip into my own memory of what disappointment felt like for me.
Precisely. Schnell writes it out explicitly in the paper. He says, cognitive empathy actually involves reference to own affective states in the observer. The hippocampus pulls up the file of what it feels like to be in that kind of situation, and the amygdala tags it with the appropriate emotional flavor.
That completely blows the cold cognition idea out of the water.
It does. It suggests there's really no such thing as truly cold empathy. At its core, it's always warm cognition. We are the ultimate reference point for everything we understand in others.
We are always reading the world through the lens of our own autobiography.
That's a beautiful way to put it. It's exactly right.
So we have these two engines, the hot engine, the feeling engine, and the, well, I guess the warm engine, the thinking engine. But unless I have a split personality, they have to be talking to each other, right? They can't just be running in parallel.
They absolutely do. In a healthy, functioning brain, there is constant integration. And a team led by Fan did a massive meta-analysis. In 2011, they looked at dozens and dozens of studies to find if there was a core network.
A bridge between the two roads.
Exactly. And they found one. The left anterior insula.
The insula, again, it's everywhere in this story.
It seems to be the great diplomat of the brain. While the right anterior insula is often more specialized for that raw, visceral feeling, the left anterior insula seems to handle the translation. It integrates the somatic signal from the body with the cognitive context from the prefrontal cortex. It's where feeling meets knowing.
But does everyone have the same kind of bridge? Or are some people just naturally wired to favor one side over the other?
That is exactly what Cox and colleagues looked at in their 2012 paper in Social Cognitive and Affective Neuroscience. They used a technique called resting state connectivity.
That's when you just have someone lie in the scanner and do nothing, just let their mind wander.
Right, you're not giving them a task, you're just watching the brain idle, seeing which parts are naturally chatting with each other. And they found a distinct bias.
A bias how?
People who self-reported as high feelers, people with high affective empathy, had stronger intrinsic connectivity among those social emotional regions. Their amygdala was constantly and loudly chatting with their orbitofrontal cortex, even at rest.
And thinkers.
People who were dominant in cognitive empathy showed stronger baseline connectivity in the social cognitive regions, like the superior temporal sulcus.
So we literally have a default setting, a path of least resistance our brain prefers to take.
It seems so. And this leads us to what I think is maybe the most critical and practical dynamic in this entire discussion, the inhibitory relationship.
Okay, this is the Stietzitz et al. Paper from 2019. This was the part of the research that honestly made me just stop and stare at the wall for a minute.
It's the seesaw effect. It changes everything.
Explain that.
Stietzen and their colleagues found that in highly emotional situations, these two systems don't just work together, they can actually start to compete.
Compete for resources.
It's more direct than that. They found evidence that when the anterior insula or feeling hub is highly activated, it can exert an inhibitory influence on the temporoparietal junction, our cognitive perspective-taking hub.
Wait. So you're saying if the feeling is too loud, it literally shuts down the thinking part of the empathy network.
It dampens it significantly. Think of it like trying to have a quiet, nuanced conversation right next to a giant speaker blasting music. If the feeling signal is screaming, if you are completely overwhelmed by the other person's pain, your brain literally loses the cognitive bandwidth to run the perspective-taking software.
This explains personal distress, doesn't it?
Yeah.
That feeling of being completely overwhelmed.
It's the perfect neural explanation for it. It explains why people freeze in an emergency. When you see someone suffering and you get so upset that you start hyperventilating and can't think straight, you become useless.
You can't help them.
You can't help them because your cognitive ability to strategize and problem solve has been taken offline by the sheer volume of the effect you're experiencing.
This has huge implications for professions like medicine or law enforcement or therapy.
Huge. If a surgeon felt the scalpel cutting their own skin every single time they made an incision, they couldn't perform the surgery.
Right.
They need the cognitive understanding of the anatomy, but they must downregulate or inhibit the affective sharing to do their job effectively.
So being professional or maintaining clinical distance is essentially a neural inhibition task.
It's actively managing the volume knob on your anterior insula so that your TPJ and prefrontal cortex can do their jobs.
That is fascinating. It completely reframes coldness not as a lack of caring, but as a necessary functional state for high-stakes helping.
Exactly. It's a feature, not a bug, in certain contexts.
I want to pivot slightly here.
Yeah.
We've talked about healthy brains and brains with very specific lesions. But what about the slow march of time? What happens when these systems start to wear down with neurodegenerative disease?
Neurodegenerative disease gives us this really tragic but scientifically very clear window into the anatomy of empathy. There's a classic study from Rankin and colleagues back in 2006 published in Brain. They looked at 123 patients with various conditions like FTLD, which is frontotemporal lobar degeneration, Alzheimer's, and so on.
And they correlated the patient's loss of empathy with where their brains were showing atrophy. What did they find?
They found that as empathy eroded, there was significant atrophy, a shrinking of the brain, in a very specific set of regions. The most significant was the right temporal pole.
The temporal pole, so that's at the very, very tip of the temporal lobe.
Right at the front. And this area is thought to be the brain's storehouse for what we call social semantic knowledge.
Social semantic knowledge. Can you unpack that for me?
It's the rule book.
Yeah.
It's the abstract concepts of social behavior. It's the part of your brain that knows funeral equals sadness and requires a quiet voice. It's knowing that sarcasm means you should interpret the words as their opposite. It's the script for social situations.
So when the right temporal pole begins to degrade, the patient literally loses the script.
They lose the meaning. They might see the tears at a funeral, but the semantic link between funeral and sadness has physically dissolved, so they might laugh, not because they're being cruel, but because the social rulebook in their brain has been erased.
That is absolutely heartbreaking. But it's also, from a scientific view, a powerful validation of the anatomy.
It is. But let's look at normal aging for a second. Because thankfully we don't all get FTLD. Does just getting older make us less empathetic?
There's a 2016 study by Moore and colleagues that looked at this in psychiatry research, neuroimaging, and they found something kind of, well, encouraging.
They did. They looked at older adults and found that higher affective empathy was actually related to a deactivation of the amygdala during emotional memory tasks.
A deactivation, that sounds counterintuitive. Usually we think more activation is better.
Not always. In this case, the researchers suggest it points to neural efficiency. A younger, less experienced brain might need to blast the alarm bell of the amygdala to process an emotional event.
Whereas an older
brain has seen it all before. It has more life experience to draw on. It can process the emotional content effectively without all the chaotic arousal and alarm bells.
So it's a form of wisdom written in the neural code.
It could be. It's a calm amygdala. And interestingly, for cognitive empathy, they found that older adults relied more heavily on the insula than younger people did. It suggests the aging brain cleverly reorganizes its strategy. It integrates a lifetime of felt experience rather than relying on raw reactivity.
Okay, now I want to bring this dual root model to the ultimate test. The clinical profiles that everyone, and I mean everyone, talks about when they talk about empathy. Psychopathy and autism.
Yes, these are probably the two conditions that are most profoundly misunderstood when it comes to empathy.
Let's start with psychopathy. The 2018 Marsh paper uses this as the primary example of the dissociation we've been talking about.
It's the textbook case. If we use our two-engine model, a psychopath is someone with a high-functioning higher route and a completely broken lower route.
The detective is working perfectly, but the mirror is shattered.
Precisely. They often have intact or even superior cognitive empathy. They know exactly what you're feeling. They can read your microexpressions, your tone of voice, your vulnerabilities. That is how they manipulate so effectively. They understand you perfectly.
So they don't feel it.
Not a flicker. They don't have the somatic contagion. When they inflict pain on you, they don't get that automatic visceral ouch signal in their own insula and cingulate that tells most of us to stop.
And the neural correlate for that, what do we see in their brains?
Marsh's review points to a consensus around structural malformations and, crucially, hypoactivation, meaning underactivity in the amygdala. The brain's alarm system is just silent.
Okay, now let's contrast that with autism, because the stereotype, and it is a very persistent and damaging stereotype, is that autistic people lack empathy.
And the neuroscience, when you look at it closely, says that is largely a myth. In fact, for many autistic people, it might be the exact opposite of the truth.
The opposite.
Well, there's a concept that's gaining a lot of traction called the empathy imbalance theory. Stevens and Tabor discuss this really well in their 2021 review in the journal Neuropsychology.
An imbalance. So not a deficit, but a mismatch.
Exactly. In autism spectrum disorder, what we often see is a struggle with the cognitive route, reading the subtle, unwritten social cues, understanding sarcasm, navigating the complex detective work of theory of mind. That can be very difficult and labor-intensive.
So the detective work is hard.
Right. But the affective route, the feeling engine, in many autistic individuals, it is not only intact, it can be hyperactive.
Hyperactive. You mean they feel too much.
Imagine walking into a crowded room and not just hearing the noise, but feeling the emotional state of every single person in that room at volume 10. It would be overwhelming, a sensory and emotional assault.
So when an autistic person withdraws from a social situation or looks away or seems to shut down,
It is very often not a sign of indifference. It is an act of self-protection. They are trying to shield themselves from a tsunami of affect because their lower root is so exquisitely sensitive.
that is a profound reframing. It basically says the behavior that neurotypical people might interpret as not caring is actually a direct result of caring too much.
Exactly. And the neural correlates often back this up. You might see reduced activation in the medial prefrontal cortex, the mentalizing network, during social tasks. But the emotional centers, like the amygdala and insula, are firing on all cylinders.
This brings us to the final piece of the puzzle then, the goal of all this. Because empathy, just feeling the pain, whether it's a little or a lot, isn't actually the end game, is it?
No, not at all. If I see you drowning and I empathize so much with your panic that I jump in the water and drown right alongside you, that's not helpful. That's just personal distress.
The goal is compassion. The goal is to actually help.
And Stevens and Tabor map out a kind of process flow for this in that same 2021 paper. It's a sequence of events in the brain.
Walk us through it. How do we get from just observation to helping?
Okay, so step 1. Distress is observed. You see the person struggling. Step 2. Affective empathy kicks in automatically. You feel that contagion, your insula fires, you feel a shadow of their distress.
Okay, so I'm feeling it. I'm in the moment.
Step 3 is the absolute pivot point, and that is self-regulation.
This is where that Steets inhibition study comes in. I have to be able to control the volume of my own emotional response.
Yes, you have to dampen that signal just enough to keep your own cognitive brain online. If you fail at this step, you spiral down into personal distress and withdrawal. You become useless.
But if I succeed in regulating,
If you succeed, then you move to step 4, which is empathic concern, or what we call compassion. And then, and only then, you engage your cognitive empathy. You start calculating, what does this person actually need? What is the best way to help? What is the cost to me?
in fine life,
Finally, step 7, pro-social behavior. You throw the life preserver instead of jumping in to drown with them.
so empathy, that initial affective spark, is crucial. But it's the regulation and the cognition that act as the fuel that allows for helpful action.
Precisely. Without the regulation, that spark just burns you out.
We have covered a massive amount of neuroscience today. Let's try to synthesize this for everyone listening. What is the big take-home picture here?
The big picture is that we really need to retire the idea of empathy as this single monolithic thing. We have, I think, thoroughly unpacked the double dissociation.
Right. We have a hot system, the inferior frontal gyrus, the anterior insula, that ancient fast mirror mechanism.
And we have the warm or cold system, the VMPFC, the TPSHA, the slower, more deliberate human detective mechanism.
They are distinct. They can break separately. But in a healthy brain, they are in constant conversation, with that left anterior insula acting as the bridge.
And the main implication of all this is that when we're struggling to connect with others, whether it's a partner or a child or a colleague at work, we need to be much more specific in our thinking.
Right. Don't just throw up your hands and say they lack empathy. You have to ask the question, is this a failure of feeling? Or is this a failure of understanding? Because the brain treats those as two completely different problems with different solutions.
And here's a final, maybe provocative thought for you to chew on, going back to that inhibition finding from the Steets paper.
I'm ready. Lay it on me.
We live in a culture that right now really valorizes feeling. We're constantly told to be more vulnerable, to feel more, to open up and share our raw emotions. But looking at the neuroscience, is it possible that sometimes the most compassionate and effective thing we can do for another person is to feel a little bit less?
To consciously turn down the volume on our own anterior insula so that our temporoparietal junction has the quiet cognitive bandwidth it needs to actually understand what the other person truly needs from us. instead of what we think they need based on our own overwhelming emotions.
Maybe true empathy isn't about bleeding with someone. Maybe it's about having the composure to stay dry enough to pull them out of the water.
That is a powerful thought to end on. It's not about volume, it's about balance.
Always. It's all about balance.
Thank you for diving deep with us today. Hopefully you understand your own brain and maybe your neighbor's brain just a little bit better now.
See you next time.